everyone. So today we are going to discuss about Argyll Robertson Pupil. So it is pupillary abnormalities in which there is small pupil, there is irregular pupil, and they respond to accommodation reflex, but they do not respond to light reflex. So it is usually bilateral. It can be unilateral, but mostly it is bilateral, and it is a late stage of syphilis, and there is a specific sign of neurosyphilis. So before we understand the pathology of Argyll Robertson pupil, it is very essential to know the anatomy of pupillary reflex pathway and accommodation reflex pathway. So here we have to know the anatomy of pupillary reflex pathway. So when light is shown, the parasympathetic fibers begins from ganglion cell layer of retina, and the axons transmit the impulse to the optic nerve, and from optic nerve the impulse projects to optic chiasma, and from optic chiasma the information projects to optic tract, and from optic tract the neurons project to pituitary region of midbrain, which is present rostral to superior colliculus, and from pituitary region of midbrain the neurons project bilaterally to the Edinger-Westphal nucleus, and the Edinger-Westphal nucleus is also parasympathetic ganglions, and it consists of three parts: dorsal part, ventral part, and caudal part. And to the more specific, the neurons from pituitary region of midbrain synapse with dorsal part of Westphal Edinger-Westphal nucleus, and the neurons from Edinger-Westphal nucleus, the preganglion fibers arise and project to ciliary ganglions through oculomotor nerve, and the oculomotor nerve is also third cranial nerve, and ciliary ganglion is also parasympathetic ganglion which is present peripherally to the apex of orbit, and the post ciliary ganglions, the post ganglion fibers transmit to short ciliary nerves, and from short ciliary nerves it transmits to sphincter pupillae muscles, and as a result there is pupillary constriction. So here we will discuss about accommodation reflex pathway, and the parasympathetic fibers begins from ganglion cell or retina, and the information goes to optic nerve, and from optic nerve the information transmits to the optic chiasma, and from optic chiasma the information project to optic tract, and from optic tract the neurons goes to lateral geniculate body which is present in thalamus, and from lateral geniculate bodies the information goes to primary visual cortex which is present in occipital lobe, and from primary visual cortex the information goes to visual association cortex which is also part of occipital lobes, and from visual association cortex the information transmit to supraoculomotor nucleus through internal capsule of corona radiata and crus cerebri of midbrain. The supramotor nucleus is present posterior to oculomotor nucleus of midbrain, and from supraoculomotor nucleus the neuromotor transmit to the Edinger-Westphal nucleus which is the ventral part, and from Edinger-Westphal nucleus the neurons project to ciliary ganglions, and from ciliary ganglions the postsynaptic fibers transmit to short ciliary nerve, and from short ciliary nerve it goes to ciliary muscles which causes lens to increase depth of focus by increasing the radius of curvature, and also from Edinger-Westphal nucleus the neurons, the information goes to medial rectus through oculomotor nerves, and medial rectus causes adduction, and as a result there is convergence of eyeball. So we understand here short ciliary nerve means constriction of pupil and increase the radius of curvature and convergence of the eyeball are the three components of accommodation reflex pathway. So here we understand in Argyll Robertson pupil there is response to accommodation, but there is no response to light reflex. And in some books there is mentioned that syphilis affect dorsal part of Edinger Westphal nucleus, whereas ventral part is spares, and as a result there is degeneration, there is affect dorsal part is affected, and due to which pupillary reflex pathway is affected, and there is so that there is no response of light reflex. So in this way we understood the pathology of Edinger Westphal nucleus.